Got a busy day ahead. Sorry about the slow start. Didn't realise the time. My dog wanted a poo walk, and it is what it is. Right, so we are going to look at what's called trig substitution. It's a very interesting type of substitution. We will not be using u subs, but what I like to call x subs. That's my name for them. And if ever you see an integral that looks like this, the square root is 16 minus x squared, the square root of 4 minus x squared, then you're going to use this substitution called x equals whatever a is sine theta. If they're added together, you're going to use a tan theta. And if one has the x squared first and then you subtract the number, you're going to use a secant theta. Now these questions are long, very long. And that's going to be all the steps that we're going to use to do one. But before we even look at a question, we're just going to do one particular skill building exercise. And that is, I'm going to show you a number of questions from the homework, and we're going to decide what x sub should be used in each case. So this one is going to be question 3. So we're not going to do the entire question, we're just going to do find the x sub. So it's an x cubed over the square root of x squared plus 49 dx. What should be the x sub, as I call it, used in this question?
Seven tangent theta.
Okay, so we're going to use number 2, and it's 7 because of that guy. Now, hopefully by the time we get to the end of this kind of list, you'll start getting much better at picking the x sub. So in this case, it's x squared over the square root of 49 take away x squared dx. Now, the only guy you're interested in is the guy inside the square root. I don't care if that says x cubed or x or 42. Doesn't make any difference. I'm only interested in this guy. Now, if I go over here and I look, do you see number 1 fits the bill? And 49 take away x squared, well, the 49 is going to get me a 7. So 7 sine theta. And that would be the x sub. So let's move on. Next one. And, it's going to be oh, it's got an a, that's nice. A squared plus x squared. Doesn't that belong to number 2? And number 2 is an a tan theta. 1 to 6. Now, a half is a square root. 3 halves is just in the member or the family of them. So x squared minus 1 is the important part. Do you recognize it's number 3? And number 3 in this case is a, which is 1. So I don't write it. Secant theta. Do a few more. It's question 7. In fact, let's just do it slightly quicker way. Just show you the questions and then we can just do them as we see them. Okay, question 7. Who looks like that guy? So if you've written down what we've got in a bit of paper, you should be able to find that guy. Who is question 7? 1, 2, or 3?
2.
2.
Agreed. And so 2 is 9 tan theta. Now, not everybody has written that down, I can tell. So we are going to have a look at that and give you a few moments to do it. Okay, Sam, you have a joke while people are writing down these 3 things. Write them down in a nice piece of paper and keep it handy, because for the next 2 days, you're going to be using this guy a lot. So what was your joke, Sam?
Why can't eggs tell jokes?
I don't know. Why can't eggs tell jokes?
Because they'd crack each other up.
Ooh, bad. Why don't mussels buy you presents?
Why not?
They're shellfish. Okay. Why are mountains so funny? Because they're hill areas. Hilarious. Megan, I'm using up a good load of material and I get nothing out of you. Hill areas. No.
Am I supposed to unmute myself every time I laugh?
That's probably impractical, that's true. It'd be nice if you did, but it'd be impractical, you're right. Okay, let's go back to that question now that those who've written down it can actually use it. I don't know where the heck we are. Are we on the screen? Can you see that now?
Yeah.
Okay, so in question 8, which one are you going to use? 1, 2, or 3?
3.
And so that's going to be what, 6 secant theta? Question 9, who are you going to use?
2.
And that's going to be 9 tan theta. Question 10, who are you going to use?
2.
And that's going to become what, 7 tan theta? And the last one, question 11. Oh, question 11 is a special one. Can anybody just look at 11 and go for it? Because they're not, that one's different from everybody else, isn't it?
1.
Agreed? Now the harder part. It should be some number or fraction sine theta, right? A sine theta. But it isn't 4 sine theta. What do you think it might be? Any guesses? Obviously, we'll be doing this one tomorrow, but it'd be cool to start it off. Last chance. 4/5 sine theta. 16/25 square root 4/5. So, not really obvious. So it's a little bit unfair. So, we built up, hopefully now, if you see an integral, you'll be able to look at what's inside the square root, and it's one of these 3 guys. So let's take you to the shopping list of how you do a trig integral, like the ones you're looking at right now. First stage, we've already done. Choose the correct x sub. Then we're going to find the dx. Step 3 is use substitution. And we're going to change the original integral so it's now in terms of theta. And then we're going to solve, right, integrate it, that's 4. And then we are going to do 5 and 6, which is how you get it back to being x's. So there is a lot of work on that. So I guess I should start right away with our first question. Version question 3. And we are looking at the integral of x cubed over the square root of x squared plus 49 dx. Okay, step 1. We've already done this, guy, but let's do the whole process now. What is the x sub that you would use in that particular situation? X squared plus 49. What would you use?
Second.
7?
7 tangent of theta.
There we go. Now what I'm going to do, well, do you know what I'm going to do next? Maybe you could tell me before I do it. It's just like a U sub, but it's called an X sub. So what do you think I'm going to do next?
Differentiate.
Agreed. And that's exactly what you do. You're just going to differentiate with respect to theta, which we all know is secant squared theta. And then we're going to do the crossover. But in these questions, you always end up with 3 lines rather than the typical 4 that you get in a U sub, because I now know what dx is in terms of theta. So that's what step 1's about. And actually, that's where step 2 is. Find dx. Now, step 3, use substitution to change the integral into thetas. So here goes. It's going to be the integral. Instead of x cubed, it's going to be 7 tan of theta cubed. Instead of the square root of x squared plus 49, it's going to be the square root of 7 tan theta squared plus 49. And instead of dx, it's going to be 7 secant squared theta d theta. Are we comfortable with replacing all the x's with various versions of tans and secants? We're good so far. Now, we need to make this as simple as possible because we're going to integrate it. And if I left it the way it is right now, we'd probably never be able to integrate it. So let's see what we can do. This guy cubed is going to be called 7 cubed tan cubed theta times 7 secant squared theta d theta. And this guy here is going to be called 49 tan squared theta plus 49. Well, I haven't done a lot, but I've done something. Every little bit helps. That 7 and that 7 can combine to give me that guy. And I'm trying to write every line I can think of, so I'm not skipping anything. What about the thing inside the square root? Is there anything you could do that might make that a little bit nicer? (49 tan squared theta plus a 49. Anything come to mind?
Take out the 49 and then square root of 49 is 7.
Oh, yep, I totally agree. And we will do that. But right now I'm just going to leave it like that for a second. But you're right, the square root of 49 is going to be 7. As I say, I'm putting every line I can think of into this question, because this is going to probably be the only one that you actually see every possible line that you could have. And hopefully quite a few of these lines you could jump from there to there kind of thing. Okay, what does tan squared theta plus 1 make you think of?
Don't have my trig card, but I know that's a trig substitution.
You are definitely right. You want to have a guess, and it don't matter if it's wrong, but what do you think it might be?
I really want to say secant squared theta, but I can't remember.
You are right. Stop there. You want it to be true, and it is. So it actually is. You can check it up later. That tan squared theta plus 1 is in fact secant squared. Now, as I say, I'm doing every possible line under the sun here, so I don't feel the need that every question from this section has to be done quite as much. That can come as a 7, as someone said earlier, and that guy becomes secant theta d theta. Where do you think we're going next?
We can divide that top bit by 7 secant theta and get 7 cubed tangent cubed theta secant theta.
Are we good so far? Right, I'm just going to move this to the top of a new line. So I'm just repeating that last line. It's 7 cubed tan cubed theta secant theta d theta. That's where we are right now. And we haven't even, well, we've kind of finished 4, right? But we haven't found what the integral is equal to. And I've been playing about with this 7 cubed for probably too long. So 7 to the power of 3 is 343, and I'm going to just stick it outside. Okay. That means we only need to worry about this guy.
Is it time for a U sub?
It is. So X subs very, very often, not every question, but a majority of them, you're going to end up with a U sub, which means that we need to remember last week's work. When you get a situation like this, isn't the U sub either a sine or a cosine, or it's a secant or it's a tan, right? It's never secant squared or tan cubes. So which one is it in this question? A secant or a tangent? Which one should I go for? 50-50. One works and the other doesn't in this particular situation.
A secant, I think.
And that is correct. Why does a secant work? Well, let's do it from the reverse. Why doesn't a tan work? Well, if you differentiate a tan, don't you get a secant squared? And would you agree a secant squared doesn't play well with a secant? So if this question had been tan cubed secant squared, can you imagine that? A different question, right? Tan cubed secant squared, I would have used the tan. I would have in that case, but not in this case. What's the derivative of secant?
Secant tan.
Correct. So du is secant tan d theta. And if you isolate the secant theta, you get that guy. So I have right now tan cubed theta, secant theta, 1 over secant theta, tan theta, du. Have you noticed that I didn't turn that guy into a u yet? It's sometimes a good idea just to leave things alone for one line. Because now I get to see something much more interesting. Do you see that these two cancel? And doesn't this one partially cancel? And so what I now have is that. Oh,
Turn the
that's not good.
tangent squared theta into secant squared theta minus 1, and then you can use your u.
That's it. So if you have this guy next to you, won't you go, that one looks good, and use it? Again, I'm putting every line in. Now, this question has traveled a long way from its original format. It originally was that guy.
Shouldn't that be u squared minus 1?
Oh, yes. You know what I'm doing? I'm integrating before I should have. That's a 1. 1/3 u cubed, take away a u, guess plus c. What do you think I should do next?
Convert it back into x's.
Well, eventually, yes, but before I do that, won't I have to convert it back into thetas?
Right.
And that's a lot of work. That's us just finished 4. Find this integral in terms of theta. Right, there it is. So what does the next thing on the list say? Construct a right angle triangle using the x sub from step 1. So put that way, hide it. The x sub from step 1 went and said the x was 7 tan theta. And the right angle triangle that we're being asked to create looks like this. You make angle theta here, and you rearrange this guy so that tangent of theta is on its own. Now, in 142 in trig, you learn a guy called SOHCAHTOA. And what SOHCAHTOA allows you to do is to find 3 trig ratios. Which one is the tangent equal to?
Opposite over adjacent. So your opposite side is going to be x and your adjacent side is going to be 7.
And then you can get the third side, because Pythagoras allows us to get the third side. And won't the third side be?
The square root of x squared plus 49.
And isn't that this guy? So when you build this triangle, one of the 3 sides better be this guy here. If he is, that's a good sign that you've been doing it right. If one of the 3 sides is not this square root guy here, then it's a very good indication that maybe something has went wrong. Now, we have an integral that we want to convert. The guy that we want to convert into x's, and we're going to use this triangle to do it, was that guy.
So secant is 1 over cosine, and cosine is adjacent over hypotenuse. So that would be hypotenuse over adjacent.
Okay, so let's take that. Let's see what you just said, because she's right. Isn't the secant 1 over cos? Well, a cosine is adjacent over hypotenuse, so won't this be hypotenuse over adjacent? So that means secant is that ugly square root over 7. So we now have 343 1/3 the square root of x squared plus 49 over 7 cubed take away the square root of x squared plus 49 over 7, add a c. We are darn close to being finished here, right? But we do have some tidying up still to do. Agreed? So, why don't I just bite the bullet? 343 over 3. Square root of x squared plus 49 cubed over 7 cubed. Take away 343 over 7. Square root of x squared plus 49 and add a c. And that guy divided by that guy, let's see what that looks like. If you take 343 and divide it by 7 cubed, you get 1. So that ends up being actually not that bad. I don't think that goes anywhere, so, well, it might. Let me
You
check
can
it.
divide it by 7 because 343 was
7 cubed, so it's 49. And this guy is actually the answer, number 6. And I'm just going to write down what that was as an original question. The integral of this is that mess.
Can you move it up a little?
There we go. So the integral of this is that. That took us about 20, 25 minutes. That is a lot of work, isn't it? And I think there's is it 11 questions, something like that? 11 of these. Although a couple of the early ones aren't as bad as that. So you know you're going to be spending a lot of time on just one of these questions. Secondly, doesn't it involve us doing all sorts of different steps? There's somewhere around about 15 to 20 lines of working in that entire question. So you're going to go through 15 to 20 lines where each line has the opportunity for you to screw it up, right? And so you have to be really, really careful. As you lot know, that's why you caught me a couple of mistakes, right? But when you do it, you don't have the rest of the class saying, hey, did you not mean x squared or x cubed, or did you drop a plus or whatever? Which will make it quite hard in one pass to get it right. So don't assume that you're doing the process wrong. Just look for algebraic mistakes or things that just you didn't quite tidy up as well as you could, you know. So we have time for one more. That's how much these are. So this one's going to be number 4, or at least like homework question number 4. And it's going to be the integral of x squared over the square root of 49 take away x squared dx. We're going to do an x sub. Anybody want to tell me what the x sub is?
3. It'll be 7 secant theta. Right?
You got me guessing for a minute. Just checking this out. 1 minus, no, it's not. Try that one. And I'll bring my guy up.
Sorry, it's a 7 sine theta.
Okay, we both agree then. So dx by d theta is 7 cosine theta. And I have to do this a bit quicker because well, we only have a certain amount of time left. Are you happy about that line? Although I zoomed through it. 7 sine gave me eventually this guy. So x squared is 7 sine theta squared. the square root on the bottom, don't know why I did that, is going to be 49 take away 7 sine theta squared. And the dx is going to be 7 cosine theta d theta. That guy gets me 49 sine squared theta. Let's do it even quicker than that. Wouldn't that get me 7 squared, and that'll get me another 7, so that's that 7 cubed guy again. Let's try this guy in the bottom in one go. 49 take away 49 sine squareds. Who could that be? 49 take away 49 sine squareds.
Cosine squared.
And 49 of them. That and that multiply together to get me 343 sine squared times cosine. This guy gets you sine 7 cosines. They cancel, that partially cancels. And so I'm now left with 49 sine squared theta d theta. It's a little bit less work than the last one, but not much. And then I need to integrate this guy. I need a method to do that. U subs is very common, but not in this case. In this case, we're going to use trig identities. Can you see a different way of writing sine squared that's going to allow me to integrate this?
One half of 1 minus cosine 2 theta.
Okay, and 1/2, I'll stick down here. 1 minus cosine of 2 theta d theta. We comfortable with that, guys? Okay, why don't I pull out the 49 and just call this guy that. I'm particularly weird about that. I should be able to integrate it. 1 gets me theta. Is it okay to write that down? Are you happy with where the -1/2 sine 2 theta came from, which is the antiderivative of cosine 2 theta? Are we good with that? Now I need to build a triangle. And this right angle triangle is going to take these guys eventually and turn them into x's for me. So here's my theta. I guess I'll do red. This is going to be the opposite. This is going to be the adjacent. And this is going to be the hypotenuse. And the x sub that I used was 7 sine theta, which if you divide both sides by 7, you get that. What's the SOHCAHTOA version of sine?
Opposite over hypotenuse.
Which now means that I can use the fact that the opposite is x and that the hypotenuse is 7. And then if you want to use Pythagoras, want to be this guy, take away that guy squared. So 49 take away x squared. And is that good news? Yes. Good sign. Okay, so I have to figure out how to turn theta into x's and how to turn this guy into x's, and then, you know, do what we can. Since I got some spare room up here, I'll do it. If x is 7 sine theta, and the x over 7 is sine theta, then isn't theta the inverse sine of x over 7, which means that I can now replace that with this. So I have 49 over 2, the inverse sine of x over 7. Okay. Take away 1/2 of something. Okay. Now I need to find the sine of 2 theta. Is there anybody over here that I can replace the sine of 2 theta with that just uses sines or cosines of theta? Because that's what this triangle is only capable of telling me about.
2 sine theta cosine theta.
And now that I've done that, I'm going to forget about that half and stick a half in here, which means it's a half of that, which really just means then that this fella is that. So it's going to be take away a sine, right? The sine of theta is opposite over hypotenuse, times a cosine of theta, which is adjacent over hypotenuse. And then I try and tidy it up a little bit more. Distribute this weird fraction, and you get that guy. That 7 and 7 is 49, which cancels that 49, so all you're left is a half. This guy. That's a bit of a challenge, isn't it? Somewhere in the region again of what, 15 to 20 lines of working? So I think the first thing we should do, in case I forget, we all say hi so we can get attendance. And now we need to think about tomorrow while I'm doing that, or you're doing that. Tomorrow, we're just going to go through more and more examples of this process. Right now, all you have seen is the whole thing being done twice. Can you imagine then that if you get more practice, it'll get a little bit faster? And if you get more practice, you might well be able to skip a couple of lines here and there of what I just did. But you're never, in these questions, really going to be able to get them onto, oh, I'll do the whole thing in 5 lines, which you can do with many integrations, but not this one, right? If you try and do one of these questions in 5 lines, you're just asking to screw up somewhere. There are just too many bits and pieces that you have to keep juggling, and you're going to drop something. And you're just going to get frustrated because the answer won't be right. And then you try it again, but you make a different mistake and it's not right a second time. And that's not fun when you do that. Okay, any questions? Are we good for today? Or we have some questions?